Okay, this is what we're studying. It's called the Pythagorean Theorem. And all we're going to do is we're going to start to look at the right triangles that we've been looking at the whole time. There's nothing new here. This is a triangle with 3 sides, and we're going to put this little corner in the, this little symbol in the corner, which means it's a 90-degree angle, and this is called a right triangle. And we've been talking about that. We've been talking about that kind of thing for quite some time. So what we're going to do is we're going to start some labeling. Okay, we're going to call this a leg of the right triangle. We're going to call this side a leg. So here we have what we call a leg of the right triangle, and here's another leg of the right triangle. And you can see that the 2 legs are just the sides next to this 90-degree angle. I mean, there's nothing special about it. There's nothing magical about it. It's just a label. Okay, so this is called a leg, and this is called another leg. The other length, we're not gonna call it a leg. We're gonna call it something really fancy. Okay, we're gonna have a really fancy name for it, and it's called the hypotenuse. Okay, nothing special here. It's just called the hypotenuse, and you know, I've drawn it in pictures here, and so I think you'll understand what it is. But in words, what you'll see in the textbook is it's the side opposite, and the word OPP I'm saying is opposite of the 90-degree angle in, whoops, okay, it's the side opposite the 90-degree angle, and it is also the longest side. Okay, let me just stop and back up, because really once you get this, once you understand what's going on here, then the rest of the actual math that we're going to do in a minute isn't very hard at all. Okay, really, when you have a right triangle, by definition, you have an angle that's 90 degrees, so you're going to have 2 legs that kind of crisscross 90 degrees perpendicular like that. That's what we have anytime you have 90 degrees, okay? The side opposite of this angle is not called a leg. It's got a fancy name, and it's called a hypotenuse, okay? It's just a word, okay? It's a very long, frightening word, but it's just a word, okay? So we put that word here. It's called the hypotenuse. Leg, leg, hypotenuse, okay? So let's get some practice in identifying the sides of a right triangle. Okay, so what we will do is do that right here. Let's say you have a triangle that looks like this. You've got something there, you got something there, here, okay? Let's say this is your triangle here. And I said to you, what are the legs of this triangle and what is the hypotenuse? Well, all you would need to do would be look at this, and you would say, well, here's the 90-degree angle. And by the way, that's how you know it is a right triangle, by definition. As you would look at this right here, this angle, and you would say, well, okay, the side opposite that is called the hypotenuse. And by the way, I'm just going to abbreviate this HYP, hypotenuse. So that means that this must be a leg and this must be a leg. So you see, we've really just turned this triangle and flipped it upside down. That's really all you have. And if you have another one, you know, just really it's the same kind of problem, but we're just doing a couple little practice things here. Let's say this is your right triangle, and you had to identify these sides. Well, then you would say, well, the side opposite of this angle is called a hypotenuse. Okay, and so then this must be a leg, and this must be a leg. The sides that are actually, it's called adjacent to the 90-degree angle. It doesn't really matter. That's a fancy word, but the 2 legs that actually come and form this angle right here are called the legs, and this is the hypotenuse. So you see, you know, we just turn this and flip it that way. So any way that works good for you. What I usually do is look at the angle and the side opposite and identify the hypotenuse, and from there you know that the other guys must be the legs of the triangle. Okay, so what we're going to do now is we're going to go ahead and define the Pythagorean theorem and work some problems. Okay, so what I'm going to do is I'm going to do that, okay, right here, okay? The Pythagorean theorem okay, is just a big long word, and it's a theorem or a mathematical truth, okay, that is applies to these right triangles. That's really all it is. So I'm going to kind of summarize it here, and then we're going to go off and work some problems. If you have a right triangle, the Pythagorean theorem only applies to right triangles, only only triangles with this 90-degree angle here, okay? If you label one leg A, and I'm going to explain this in a second, and you label other leg B, and you label other leg, whoops, there's no other leg, that was a trick. You label the hypotenuse, which I'm just abbreviating with HYP, and you abbreviate that with a C, okay? Then the following is true in a right triangle. C squared is equal to A squared plus B squared. And again, I'm gonna make this clear here in just a second, but a picture's worth 1,000 words. So in this particular case, you have a right triangle, okay? This leg is A, this leg is B, and the hypotenuse is C. That's all we've done here. Now let's talk about this, because I've written a lot of stuff down that doesn't make a lot of sense at first. What you have is a really fancy thing called the Pythagorean Theorem, and it applies to these things called right triangles. All you have to do is draw your right triangle, okay? Here we've called this a leg, and here we've called this a leg, and here we've called this an hypotenuse, which is true. All you got to do is remember that in all of these equations, C, the letter C is typically associated with the hypotenuse, okay? So if when you draw your triangle, you make C the hypotenuse and the other two legs A and B, it doesn't really matter which one. This can be A and this can be B, this can be A and this can be B, but you label these legs A and B. That's what I'm trying to say right here. Then the following equation is true. C squared, which is the length of the hypotenuse squared, okay, is equal to A squared plus B squared. Why is that the case? I don't know. That's the world we live in. When you draw a triangle, this is true. If you get a ruler and you measure the length of this hypotenuse and you square it, multiply it by itself, and you remember that number, and then you take this leg and square it, and you take this leg and square it, and you add these two things together, which is what you're doing. You're adding up the squares here. Remember, in algebra, you always do the squaring first, and then you add them up. When you do that, the number you get is going to be equal to the length of the hypotenuse. And you can see why that's, this is geometry, but it's really useful in real life. I mean, you could have any number of things that you're doing in real world if you're trying to calculate I don't know, let's just say you're in a football field and it's a rectangular football field, and you want to see how long it would be to run from one diagonal corner of the football field to the other, right? Well, you can get your tape measure out, right? And you can measure it, of course. But let's say you didn't have that. All you had was the lengths of the sides of the football field. Well, that diagonal is the hypotenuse. That's what you would want to calculate, right? If you know the length of one side of the football field and the length of the other side of the football field, and then you square them and add them together, you're going to get the hypotenuse, the length of the hypotenuse. Well, you're going to get the square of the hypotenuse, but you can just take the square root and arrive at the hypotenuse. And we're going to show you how to do some problems like that right now. Okay. So we want to solve the following problem. Let's say you have a right triangle that looks like this. How do we know it's a right triangle, by the way? Because we've got this little funny symbol in the corner that always tells us it's a right triangle. And the problem will have a number here that's 12. The problem will have a number there that's 9. That means that this is a length 12 and this is a length 9. By the way, my picture isn't drawn to scale, so you have to bear with me here a little bit. Okay, and the missing length we're going to call C, okay? And that's what we want to find. Well, notice that C is the length opposite of that angle, so it's the hypotenuse. So because this is a right triangle, and because you know two of these sides and you need to know the third one, the Pythagorean theorem applies. So all you have to do is you have to say, okay, C squared is equal to A squared plus B squared. That's the formula you have to remember, the equation. We're trying to solve for C squared, right? And we're going to say that these guys are A and B. Okay? So all we do is we say C squared is equal to, let's say A is equal to 12. 12 squared plus 9 squared. We're going to say b is equal to 9. Okay, so then c squared is equal to 144 plus 81. So then c squared is equal to 225. So now you know what c squared is, but in order to find c, you have to, when you're solving this equation, you do the opposite. The opposite of a square is a square root, okay? So you have to take the square root, right? So then c is equal to the square root of 225, and you can just pop that in your calculator, and what you'll get is 15. So this is actually equal to 15, okay? Now, you see it kind of makes sense because we said that the hypotenuse is always going to be the longest side of the triangle, and look, it is the longest side. I mean, it may not be drawn that way because my artwork isn't very good, but the length of it is the longest side, okay? And you can see that this is, can be kind of useful if you're doing some kind of measuring in the yard or the backyard, and you have two lengths of the triangle and it's a right triangle, and by the way, it has to be a right triangle, okay? Then you can do something like this. In this case, we're solving for c. Now, one thing I want to point out to you is notice I said it didn't really matter which one was A and which one was B, and you can see why here. In this one, I said 12 was A and 9 was B, but if I had flipped that for whatever reason and said this one was B and this one was A, it's not going to matter in the answer because they're added together. You just square them and add them up, and it really doesn't matter. And that's why I said over here, you label one leg A and you label the other leg B. It doesn't matter which leg is which, as long as you make sure that these are the legs you're talking about, and you'll get the answer correct either way. Well, let's go ahead and work another one. Okay, let's say here's your triangle. Okay, it's a right triangle only because of the symbol, which means it's 90 degrees. Now let's say in this triangle, one leg has 5, a length of 5, and they give you the length of this side, which is, by the way, the hypotenuse because it's opposite of this right angle. And now you wanted to find the length of the other side, b. Okay, so what you want to do is you don't want to solve for the hypotenuse like you did in this problem. You want to actually solve for the length of this other side. But the same equation applies. Okay, the same equation applies. Let's figure out how. Okay, so in this problem, I'm just going to write something down to make it clear. C, which is the hypotenuse right here, C is always the hypotenuse. The length of the side opposite of this right angle is 13. A is equal to 5, and B is equal to the question mark. That's what we want to find out. But A is equal to 5, which is one of the legs of this right triangle. So like I said, the same equation applies. C squared is equal to A squared plus B squared. Okay, C was equal to 13, so 13 squared is equal to 5 squared plus B squared. I just put 5 in here, 5 squared plus B squared. Okay, 13 squared, when you put that in the calculator or you do that by hand, is 169. And 5 squared is going to be 25 plus B squared is what I'm solving for. Okay, so how do I solve for this? Well, I take this 25 and I move it over here by subtracting it because I need to do the opposite and move it over here. And here it's positive, so in order to subtract it off, I do that. So 169 minus 25 is going to be 144 is equal to B squared. So all I did here was subtract 25 from both sides. It disappears from this side because 25 minus 25 is 0. And when you move it over here, it becomes 144. 169 minus 25 is 144. So now you just need to do this. And again, as I said before, here it's B squared you have. In order to find B, you take the square root of 144. And that is simply going to be 12. So the answer to this problem is 12. B is equal to 12. Okay, so you see that the Pythagorean theorem applies not only to solving for what C is. I mean, the equation says C squared is equal to A squared plus B squared, but you can solve for any length as long as you have the other two. Now what I want to do is talk about what we call the converse of the Pythagorean theorem. Okay, up till now, you were given a picture of a triangle, and you knew that the triangle was a right triangle, and you applied the Pythagorean theorem to find the length of one of the other sides, okay, when you had the length of 2 given to you. That's the problems we've just done here. Now we're going to do what's called the converse. Converse is just a fancy word you're going to find in geometry. It just means let's do the reverse. It's kind of like let's go backwards. That's what the converse means. So this is just a bunch of definitions. It's just you have to understand what they mean. Okay. So what we're going to do is instead of giving a right triangle, let's calculate one of the sides. Now we're going to be given the sides, and we're going to go figure out if it's a right triangle. And we're not going to have a picture of that triangle necessarily. So let's go ahead and do that. So you might have a problem, that would look something like this. Is this triangle right? Okay. That's the kind of problem you'll have. And so what they'll do is they'll draw something that looks like this. They'll say this is 3, this is 4, this is 5. But notice they did not tell you, they did not put a little symbol here to tell you this is 90 degrees, okay? You don't know if it's actually a right triangle or not. They're asking you to tell them if it is a right triangle or not. And all you have is the lengths of these sides. Well, one thing that you know is that the Pythagorean Theorem applies only to right triangles. So you should be able to apply it to this, and if the equation is true, if c squared is actually equal to a squared plus b squared, then this must be a right triangle, and that's what we're going to do here. So in this case, a is equal to 4, b is equal to 3, because this is what I'm going to guess here, and c is equal to 5. And if you're not really quite sure exactly which ones to apply to which, remember the hypotenuse is always the longest side. So if this is a right triangle, the longest side has to be the hypotenuse, which has to be c, and it has to be 5. And the other two, the legs, it doesn't really matter. I just put a as 4 and b as 3. It doesn't matter if I flip the order of those or not. As long as I got the hypotenuse right, I'm going to be okay. So what I'm going to say is c squared is equal, with a question mark, to a squared plus b squared. Because I'm not sure if c squared is actually equal to a squared plus b squared. That's why I put a question mark to remind myself, to ask myself the question. So c is 5, so I'm going to have 5 squared equals, okay, a squared plus b squared, 4 squared plus 3 squared. So all I did was plug these two guys in there. 5 squared is 25. I'm going to go ahead and put my little question marks here. 4 squared is 16 plus 3 squared is 9. All I did was square these guys here. And then 25 is equal to 16 plus 9. I think you all could convince yourself that that's equal to 25. So because this equation was satisfied, because c squared, right here, squared, was actually equal to a squared plus b squared, and that's what we've proven here, because this is true, then this is a right triangle. Okay? This is a right triangle. If this were not true, if you had 25 on the left, and let's say the lengths of these sides gave you like 10 on the right, then you would not have a right triangle, you have something else. And the picture wouldn't look like this if you drew it, okay? But mathematically, all you need are these numbers, and the Pythagorean Theorem will tell you if it's a right triangle or not. So you see, the math is not hard, you just have to understand the terminology. Let's do another one of these. Okay, let's go ahead and do another one of these. I'm going to do it right here. Okay, let's draw another triangle. Again, I have no idea if this is a right triangle or not, but they say, okay, here is the length of that side, here's the length of that side, and here's the length of this side. Okay, all I know is that the longest side in this triangle is 6. So if it is a right triangle, C must be equal to 6. Then A, we're going to say is equal to 4, and B, we're going to say is equal to 5. The legs of the proposed right triangle, okay? And we're going to say that c squared is equal, with a question mark, to a squared plus b squared, okay? And we're going to see if this is true. So c is 6, so we're going to say 6 squared is equal to 4 squared plus 5 squared. We're just plugging in a and b. 6 times 6 is 36, and we're going to put a question mark to remind ourselves to ask. 4 times 4 is 16. 5 times 5 is 25. Okay? And so what we're going to do in this step is we're going to add these guys together, and we're going to see that we're going to get 41. Okay? 16 plus 25 is simply equal to 41. So this was not equal, so this is not a right triangle, okay? Because they're not equal. In this case, they were equal, and we knew it was a right triangle. This equation satisfied these lengths, whereas this equation does not satisfy these lengths, so it can't be a right triangle, okay? This is not called a hypotenuse. These are not called, you know, these are not, does not fall into the bucket of a right triangle. Okay, now let's go ahead and switch gears a little bit. Well, it really isn't switching gears too much. It's very much related to what we're doing here. Here we applied c squared equals a squared plus b squared to figure out if a triangle was right, okay? And now we're going to use the Pythagorean theorem in a little bit different way to tell us a little bit more about a triangle, okay? So here's a theorem, and I'm just going to put it up here on the up here on the board, and we're going to apply it to a few problems, okay? If c squared is greater than a squared plus b squared, and I'm going to explain exactly what I mean by that right now, then we're going to say that the triangle is obtuse, okay? And if c squared is less than a squared plus b squared, we're going to say that the triangle is acute. Okay, so like I said, we're using the Pythagorean theorem, but in a slightly different way. Let's back up here for a second. We know that if c squared is equal to a squared plus b squared, we have what we call a right triangle. In this case, we said that c squared was not equal to a squared plus b squared, so all we said here was it's not a right triangle. Here we're going one step further, and we're not necessarily just looking for equality here. We're actually looking for how big this quantity is, c squared, compared to this. And if c squared is greater than this, we're going to say that this is called an obtuse triangle. And by the way, obtuse triangle just means one of the angles is obtuse, a very big open angle, okay? We've talked about that before. And if c squared is less than a squared plus b squared, we're going to call it an acute triangle, which means that all of the angles inside the triangle are all acute angles less than 90 degrees, and we talked about that earlier. So we've looked at the triangles and we've looked at the pictures to figure out acute and obtuse triangles. Now we're actually going to calculate with numbers if they're acute or obtuse. Okay. Let's see here. One more thing I'm going to do just to kind of draw you a picture, because I think a picture is worth 1,000 words. For the acute triangle, just to remind you, that would look something like, if I had A and B and C, all the angles inside are acute. That would, if we calculated this, if c squared was less than a squared plus b squared, the triangle would probably look something like this. And if it was obtuse, the triangle would probably look something like this, with a big open angle in there. You'd have a side like this, and a side like this, and a side like this. And it would be a big open obtuse angle. I'm just doing that mainly to refresh your memory, okay? On what acute and obtuse triangles actually are. So let's go ahead and work a problem or two, and let's go ahead and figure out if the following triangles are acute or obtuse. All you're given on your test is it says something like a triangle has the lengths 7, 7, and 10. Is the triangle acute, obtuse, or right triangle? And you have to figure that out. Well, the first thing is the longest side is 10. So you always start with that and you say, okay, fine. C is equal to 10. And then the other two sides, I'm just going to go ahead and label. A is equal to 7, B is equal to 7. And I'm going to apply the Pythagorean theorem and see what side's bigger. Okay? So what you do here, sometimes it's nice, and you see this in the books, is you can make yourself a little table. Okay? You can make yourself a little table, because you're going to end up comparing c squared to this quantity a squared plus b squared, is what we're doing up here. Okay? C is 10, so 10 squared you would have on the left, and on the right you'd have a squared plus b squared, 7 squared plus 7 squared. Well, 10 squared is 100, 7 times 7 is 49, plus this 7 times 7 is 49. So on the left you have 100, and on the right you have 98, 49 plus 49. So you can see that c squared is bigger than a squared plus b squared. So we fall in this category. C squared is bigger than a squared plus b squared. So then you know from this information that the triangle is obtuse. Okay, it's an obtuse triangle, and that's exactly what that tells you right there. If you were to put these lengths down and draw them, you would see something that looks kind of like this. You would see one angle really open, and that's what an obtuse triangle is. Okay, next problem. You're given on a test, a triangle has a length of 10, another side has a length of 6, and another side has a length of 8. Tell me if that's an acute triangle, an obtuse triangle, or a right triangle. Well, you would do the same thing. You would look and you'd say, well, the longest side is 10, so I'm going to say that C is 10, and I'm going to say A is 6, and B is 8. Okay, because these are the other two legs there. And I'm going to go ahead and use the Pythagorean Theorem. And I would say, okay, I'm going to go ahead and make this table, because that's a good way to do this comparison. Okay, and I'm going to calculate this out. C is 10, so you got 10 squared here. A is 6, so you got 6 squared, plus B is 8, and you got that squared. So 10 times 10 is 100. 6 times 6 is 36. 8 times 8 is 64. Okay, so on the left you have 100, and I think you can convince yourself if you add these two together, you have 100 here. So in this case, this is very similar to what we were doing before. C squared is 100, A squared plus B squared is 100, so we've proven that C squared is equal to A squared plus B squared, and we've already done problems like that before. What does that prove? When they're equal, that means that this is a right triangle. Because we've already stated, in a right triangle, C squared is equal to A squared plus B squared. That is just a fact. Okay, so we're going to do one more problem. And this one they'll say, you know, here you have one length is 5, one length is 6, and one length is 7. Tell me if this is acute, obtuse, or right. And so you would do the same thing. You'd say that C is going to be 7 because that's potentially my hypotenuse. That's the longest side. A is equal to 5, and B is equal to 6. And let's go ahead and apply this. C squared, and we're going to have A squared plus B squared. Okay. C squared is 7. A squared is 5 squared plus B squared is 6 squared. 7 times 7 is 49. 5 times 5 is 25. Plus 6 times 6 is 36. So I have 49 on the left. 25 plus 36, I think you can convince yourself, is going to be 61. Okay, so in this case, the hypotenuse, C squared, is less than A squared plus B squared. That's all this means. Okay, and we had the words written down up here before, and you can rewind and see that. So in that particular case, it makes it an acute triangle. So all this means is that if you were to take these three sides and actually try to draw an actual triangle with the length of 5, the length of 6, and the length of 7, there's no way that you can arrange those other than to arrive at an acute triangle, which means that all of the triangles have acute angles. So it's not going to be the spread out open triangle with an obtuse angle. All of the angles are going to be less than 90 degrees inside of that triangle. So in this section, we've tackled a really important section of geometry called the Pythagorean Theorem. You use this particular section all the time in geometry and also in algebra and trigonometry, and gosh, you use this thing all the way up into calculus. It's a really important fact of triangles. And when you know the three sides of a triangle, you can figure out if it's a right triangle or acute or obtuse by using this equation, C squared is equal to A squared plus B squared, and comparing the two sides. You can also use it to calculate the third leg of a triangle or the hypotenuse of a triangle if you know the other two. So you can use it for a lot of really useful things. And that is an introduction to using the Pythagorean Theorem.
Learn anything at mathandscience.com.